Pythagorean Formula, Part 1. In today's lesson, students will find the distance of a segment using Pythagorean formula. Using what? Very good. So now that you're familiar with measuring slope, what's slope again? Rise over run. We can use this to find the distance of segments. And a segment is a line that does not have arrows anymore, okay? The line has 2 points, right? Just like you need 2 points to find slope. And so it is a line that is finite. It has a certain distance. So to find the distance of a line segment. Remember, a line segment doesn't have arrows. We can measure the distance, has 2 points. What we're going to do is we're going to count and label the slope, basically. What's slope again? It's rise over run. So write rise over run. And when we do that, we create a special shape. Do you remember what it is? Yeah, it's a triangle. It's called a right triangle. Right triangle. Okay? So, take a look at the line segment for a moment. This is a segment. You'll be asked, what is the distance of this segment? All right? So, all you have to do is use rise over run. So, when you talk about rise would come straight down at a 90-degree angle, and we're forming a triangle. The run would go across. You'll see this on a coordinate plane. So I'm just going to give you an example. Let's say I measured this to be a certain amount of inches, okay? And I measured it. Let's say, you know what? This is 3 inches, for example, and this is 4. Yeah? So the rise is 4. Remember from yesterday, the rise is 4, the run is 3. How can I use basically the slope to figure out, well, what is the length of this missing side? Instead of measuring it, we can use something called the Pythagorean Formula. So capitalize P, because this was a mathematician, okay, that made this formula. Pythagorean, P-Y-T-H, Pythagorean, okay? For short, I just call it Pythag, yeah? The Pythag formula. To solve for the, and another word we can use for distance that you're probably more familiar with is length. The length of the missing segment, or just the length of this segment. All right? So, the Pythagorean theorem is saying that the 2 sides of the right triangle, if you square them and add them together, that would equal the length of the longest side, which we actually call this the hypotenuse. It is always going to be longer than these 2 sides. It'll be equal to that length squared. So I created a square and square root chart so that you could see that squares and square roots are opposite, okay? The reason why we're squaring distance is because distance always needs to be positive. Okay? And in this case, it always will be. So let's take a look at it. Do we remember what 1 squared is? 1 squared is the same as 1 times 1. So what's 1 squared? 1 squared is, like I said, it's the same as saying x times x, which is 1 times 1. So 1 times 1 is 1. Now, if we want to do the opposite, we want to undo it. Yeah, we want to basically find out, well, what was it before we squared it? That's what a square root does. So I want you to practice writing square root. If we want to find the square root of 1, well, guess what? It's actually 1, which means it's x, whatever this was. Make sense? So it's the same for 1. Let's talk about 2. 2 squared. 2 squared is 2 times 2. Now, what's 2 times 2? What are you going to write? 2 times 2 is 4, right? So 2 times 2 is 4. You should be familiar with this. Now, how do you undo a square? The opposite of a square is a square root. It's what? A square root. So I want you to write square root, kind of looks like a square in a way. The square root of 4. If I talk about what is the square root of 4, I'm going to see the square root of 4 equals what? It says x. So x was originally 2, right? Because the square root of 4 is saying what number times itself gives you 4? Well, 2. Make sense? Let's try 3. So what is 3 squared? It's saying 3 times 3. What's 3 times 3? 3 times 3 is 9. Very good. So now I want to do the opposite of the square. So the opposite of square is square root. It's what? Square root. So you're going to write the square root of 9. Basically, I want to undo it. What is the square root of 9? What number times itself gives you 9? It's 3. All right? Let's try 4 squared. 4 squared means 4 times 4. What's 4 times 4? 4 times 4 is 16. All right? If I want to do the opposite of square, I do square root. What do I do? Square root. So the square root of 16 is what? What number times itself gives you 16? It's 4. You getting it yet? All right. 5 squared. 5 squared is 5 times 5, right? 5 times 5 is what? 25. That was like our example, right? If I want to undo the square, I do the square root of 25, which is just what? The square root of 25 is, what number times itself gives you 25? 5. Let's try 6 squared. What is 6 times 6? 6 times 6 is 36. Very good. All right. If I want to undo the square, okay, do the opposite of square, it's square root. The square root of 36 is asking, what number times itself gives you 36? 6, isn't it? Good. Last one, 7 squared, which is 7 times 7. Who knows 7 times 7? 7 times 7 is 49. Now, let's undo the square by doing the square root of 49. What's the square root of 49? Square root of 49 is 7. Do you see the pattern? Yeah? Okay. So the square undoes a square root, starting with your original number. Now, for the answers, though, when you find distance, it is acceptable to leave them in square root form. There is this button on your calculator if you want to use it, okay? But on a lot of these, if they're not perfect squares, you're going to be getting decimals. So let's find the distance of this line segment. A line segment is a line that ends in 2 points. In order to find this distance, we need to use the rise and the run. So the rise is going to be the vertical distance. Rise is what? Vertical, up and down. Okay, and it's represented with the letter A. Letter what? And the run is going to be, you know, the horizontal distance. What kind of line is this? Horizontal. And it's represented with the letter B. Which letter? B. Don't get this confused with y-intercept. So let me explain what this means. We're going to be drawing a triangle. So take a look at this segment right here, all right? If I make it a little bit larger, I have a segment, right? All I'm going to do is create a right triangle. Now, these are 2 legs. This would be the rise, which would be A. Are we clear? Okay. The run would be B. We're looking for C. We do not know this distance. So we have to count the units down and across, always. So let's go ahead and find it here. Okay, remember this is a right triangle. So we need to make the line straight down. So how many units do we go down here? We go down how many? 1, 2. All right, now here's the trickiest part. Because this is distance, you don't need to write -2. You could just write 2 units. Are we okay with that? All right, so the rise is 2. What's the rise? 2. What about the run, the horizontal distance? The run is 1. Very good. So the run, which is B, is 1. We're going to take A and B, those are the legs of our triangle, square them, add them together, and that should give us our distance squared, okay? This long side, which is C, is called the hypotenuse, and we're trying to figure out what its length is. So let's substitute A. What's A? It's 2. What's B? It's 1, all right? After we substitute, it's telling us we have to square the sides. So what's 2 squared? 2 squared is 4. Very good. All right, great. And then what is 1 squared? 1 squared is the same as 1 times 1, right? What's 1 times 1? It's 1. Very good. Now, we have to add 4 and 1. That's what this line is for. So what's 4 plus 1? Plus 1. We're adding the sides. It is 5. Now 5 says that it equals C squared. But we're looking for C. So in order to get C, we have to undo the square by using a square root. By using a what? Good. So you're going to draw a square root, which looks like this. Okay? Over the C squared. And whatever you do to one side, you have to do to the other. So we're also going to take the square root of 5. Now, square root of 5, you will write the exact same thing on this because C will now equal the square root of 5. But what I'd like you to do is use a calculator to give me an approximation, okay, we're rounding, of what this distance will be as a decimal. So you're going to get your calculator. You're going to enter 5, see? And then, do you see the square root button right here? You're going to press square root. And you get this very long, irrational number. It goes on forever. So we're going to round it to the nearest hundredth, which is 2 points after the decimal place, and we're going to round, right? So it's going to be 2.236. So we're going to take that 6 and round up. So the answer is going to be 2.24. All right? Meaning that if this is 2 and this is 1, then this is approximately the square root of 5, right? Or 2.24. Go ahead and get. Now let's find the distance of the line segment for number 2. So, the first thing you have to do is draw a triangle. Draw a what? Triangle. Okay? Using rise over run. So rise is the vertical distance, and then run is the horizontal distance. We'll do that to create a right triangle. We're creating a right triangle so that we can use Pythagorean formula to solve for this distance here. Okay? So from this point, it doesn't even matter what the point is, you want to go straight down, rise down, and then we're going to run over. And I know in both cases, we're going down and to the left, but the distance that we're going to count these units are going to be positive. So I'm going to make some jumps to show you what is the distance, okay, down. So 1, 2, 3, 4. Okay. That means the rise, the vertical distance is 4. It's what? 4. Cool. And the run, how many units? We're just jumping units. 1, 2, 3, 4, 5. Okay. So what is the run? The run is 5. Cool. So we're going to take 4 and 5 and plug them in for A and B, substitute, into where you see those parentheses. So what is A again? It's 4. Very good. And what's B? B is 5. All right, so you substitute it. Now we have to square both of the legs of the triangle to find this distance. So what is 4 squared? 4 squared is? It's 4 times 4, right? 4 times 4 is 16. And you remember what 5 squared is? 5 squared is 25. Very good. Now at this point, you may not know what 25 plus 16 is, but that's the next thing you're going to do. You're going to add these two numbers. What is 16 plus 25? Do we know? It's, should we use a calculator? 16 plus 25 is 41. Very good. Okay, so 41 equals c squared. Now you're looking for what c is, because this is a and this is b, right? So we have to undo this square. How do you undo a square? Say, square root. So you square root both sides, right, of the equation, the formula, and then you can write square root of 41 again, because that is more precise. But what I want you to do is know how to find a square root in your calculator. So you're going to enter 41, and then you're going to press square root, this button right here, okay? So you're going to find a very long decimal. We want to round to 2 places past the decimal. So that's going to be 6.40, because that's 3, and it would not round up. So 6.40. All right, go ahead and get that down.